Welcome to mathematics, and today I'm here with another video for A-Levels paper Pure Maths 1, paper code 9709, paper 12, May-June 2024. So let's begin. So question 1 says, the coefficient of x squared and the expansion of 1 minus 4x to the power 6 is 12 times the coefficient of x squared and the expansion of another term, that is 2 plus ax to the power 5. Find the value of positive constant a. Okay, so how do we expand these brackets? There are two ways to do it. One is to expand it by using binomial expansion, both of them, and then identify which one is the x squared term and then take the coefficient. And the other way of doing it is to use the term formula for it. The term formula says TR plus 1 is equals to NCR, A n minus R, and B to the power R. Okay, so we can use this to directly get the x squared term. Okay, so using this firstly for 1 minus 4x to the power 6. So we have TR plus 1 would be equals to 6CR. First term is 1. N minus R would be 6 minus R. And B is your minus 4x to the power R. So we'll just take separate x to the power R. Okay, so we will be getting 6CR. 1 to any power will be equals to 1, so just ignore this term, and then we will be getting minus 4 to the power R and x to the power R. Now when we get isolated x with some power, so now we equate this. Which expression do we need? Which term do we need with x square? So we are equating this x square with xr. As the bases are same, so we can compare the powers. So that means r is equals to 2. Okay, now substituting back this r equals to 2 in above equation. So we will be getting t 2 plus 1 equals 6c2 minus 4 to the power 2 and x to the power 2. So solving this all, 62 gives you 15. 4 to the power 2 is 16, minus will change into plus after squared. Yeah, so this will give you 240 x squared. Okay, so this is your for the first one, first bracket. Now we are going to use the same term formula for the second bracket. I'm doing it side by side so that we can get both of them sideways and easily look into them. So 2 plus ax is your second term, 2 plus ax to the power 5. Okay, so expanding, we again need the x square. So but first we should be applying this formula because all a and b and n are different now. So 5CR, a is 2 to the power n minus r, so 5 minus r, and b to the power r, that means ax to the power r. then we get it to be, yeah, we can just need x to the power r separately. So a to the power r and x to the power r. Now we are going to compare. What do we need? X square term. So x square will be equals to x to the power r. So we have the same basis. So comparing the powers will give you r equals to 2. Again, the same thing. Okay. Now, putting this back in the above equation, this r value. So it will be r 2 plus 1 equals 5c2 to 5 minus 2, 2 to the power 5 minus 2, e to the power 2, and x to the power 2. Okay, so 5c2 is 10. We use the combination. 5c2 is 10 directly from the calculator, and 2 to the power 5 minus 2 is 2 cube, a square, x square, and 2 cube is 8, so 8 times 10 would be 80, a square, x square. Okay, now understand what they have told us in the start. What is the relation between these two things? That the coefficient of x square, whatever is the coefficient of x square, this is x square coefficient, is equals to 12 times the coefficient of x square in the second term. Okay, so I'm taking this, the coefficient of x square in the first bracket is 240. So 240 is equals to 12 times the coefficient of the x square in the second bracket, and that is 80a square. Okay, so now solving this, it will give you a square to be equals to this. First let's multiply. 12 times 8 would be 9, 82 would be 960. A square will be equals to 240, and then a square equals 240 over 960. So this will give you 12 over 48, 1 over 4. This is a square. So a would be equals to plus minus 1 over 2. Now, after this, we have to decide is a positive or negative. So they say find the value of the positive constant a. So that means our a is equals to 1 over 2 or 0.5. So this is your whole working for your question number 1.